In this video, we'll be doing product rule and quotient rule. The point of this is that before this, in the previous videos, we've been differentiating y, of which it's just a function of x, right? Okay, now what if in this case, you have two functions multiplied together? Okay, so for example, we have y equals to sine x times e to the power of 3x. Okay, now we see in usual cases we have y equals to sine x plus e to the power of 3x. If it's a plus, your dy dx is equals to, you differentiate sine x on its own, and then you differentiate e to the power of 3x on its own, right? Which gives us cosine x plus 3e to the power of 3x. Okay, so this is what we usually do, right? This is this, and this is this. Okay, so when you have plus, you can differentiate them on their own and add them together. Okay, but when you're multiplying two functions together, you cannot do that. Okay, you cannot do this, and then you multiply by this. Now that is wrong. All right, so this is wrong. You cannot multiply them together. You must do something called the product rule. So the product rule just means that if you have two functions multiplying together, first, I'll just put the blue one and the purple one and the red one. All right, red one. So the blue function is sine x, and the red function is e of 12. Now sine x, I'll leave it to be, I'll represent sine x as u. Okay, this is u, and the red one will be known as v. Okay, so v is equals to e to the power of 3x, and u is equals to sine x. Alright, so there are two different functions that both must have x. Alright, both must have x. Okay, then you can, the answer for y will be equals to what u is times dv dx plus v of du dx. This means that, for example, in this situation, what is for u, okay, u is sine x. What is dv dx? dv dx means you differentiate v with respect to x, right? So it's actually just you differentiate this e to the power of 3x, okay, and then you add v, which is e to the power of 3x, and then multiply it by du dx, which is d dx of sine x. And so the answer is sine x times 3e to the power of 3x, because this becomes this. Okay, you differentiate the d dx of e to the power of 3x means you differentiate e to the power of 3x. That's all. It's not, it looks complicated, but it's not. Okay, add e to the power of 3x times cosine x. Okay, so dy dx is just like that. Okay, and next we will do the quotient rule, where you have y equals to maybe sine x divided by e to the power of 3x. Okay, so in this case you have sine x. Okay, you can write it in the u over v form. Okay, so your u is sine x. Okay, and v is e to the power of 3x. Now you can similarly, you cannot do d dx of sine x over d dx of 3 to the power of e to the power of 3x. Okay, it's not the same. Okay, your dy dx cannot be done like that. It's wrong. Okay, so you okay, now remember that before this we saw that y equals to 3 of, let's say, a function of x, right? Now dy dx is just 3 times you differentiate this. Alright, so like, let's say if 3 of let's say ln sine x, very complicated function. I mean, seems complicated, right? So if you want to differentiate, your dy dx can be just take the constant, replicate the constant, and then you differentiate whatever x belongs to. X belongs to this function, right? X belongs to this function, right? So you just bring this whole thing down and you differentiate it, and then you multiply by 3, right? But that's because this is a constant, okay? Because the 3 has nothing to do with x, okay? So, and since, okay, so in this case, when you see u divided by v, alright, what you do is you just follow this method of your dy dx will be equals to v of du dx minus u of dv dx divided by v squared. Okay, now what this means is you just see what's on top and what's on bottom. On top is u, bottom is v. So your on top, you just follow this equation, dy dx for y will be in this v minus e to the power 3x. Okay, I mean, I'm trying to just show you what's happening. And du dx is d dx, what is u? Sine x, right? So you differentiate sine x. Okay, so this expression means differentiate sine x. Okay, wait, I'm going to draw it in the bottom. Okay, I have no space here. So, erase here. Woo! Okay, so your v is actually e to the power 3x times your du dx, which you differentiate the top. Okay, differentiate u, which is sine x. Differentiate it with x, which is d dx of sine x. Then minus u, which is sine x, and dv dx, which is you differentiate the bottom, which is v is the bottom, right? Differentiate it, e to the power 3x, divided by v squared, which is e to the power of 6x, correct? Because e to the power 3x squared is e to the power 6x. So this d dx of sine x is the same as cosine x, correct? And this differentiate this, e to the power 3x is 3 e to the power 3x. So you just expand everything out, you get your answer. Okay, so product rule, quotient rule, straightforward. Just follow the formula, memorize the formula. Now, the most important thing for the quotient rule is this, that you remember the minus sign is important, right? So what's in front and what's behind must be accurate. Okay, you must use v du dx at the front, minus u dv dx at the back. How to remember? So remember that v, okay, remember that first, you must multiply v with the differential of the other one. So v always goes with du dx. V does not go with dv dx. Okay, so v goes with du dx, u goes with dv dx. So it's the opposite. Okay, and then the one that is in front of the minus sign is v. Just remember it's v du dx. Okay, so make sure it's this. And the one at the bottom is also v. Okay, divide by v squared, not u squared. Okay, so this is the quotient rule, and before that we've done the product rule, which is that's straightforward.